Hi, I'll be your narrator for this do-it-yourself tutorial on how to build a SolNbox. A SolNbox is an all-in-one solar electric power generator that converts and stores sunlight into electricity for later plug-and-play use, day or night, indoors or outdoors. In turn, that enables you to avoid buying electricity from your utility company, which saves you money. But best of all, no fossil fuels are used to make your electricity, and that means that your clean, green, homemade solar energy is helping our shared planet. We hope you'll find this both entertaining and informative. We would also like to let you know that we've put together a DVD and a written instruction manual for this project and a parts kit so you can have everything you need to build this device without having to hunt down the components on your own. To buy your kit, which is completely optional, just visit us at www.solnbox.com. We also sell fully assembled units for those who might be interested. When you visit our site, click on the menu button to register, and you'll be redirected afterward to a PDF file of instructions, these instructions actually, and images along with other useful information. It'll come in pretty handy when you actually sit down to assemble your unit. Well, let's get started, shall we? The first step you're going to need to do is to gather some of the components necessary to build this. The things that are absolutely mandatory are, obviously, a solar panel. We recommend one that's 25 to 60 watts. Next, you're going to need 4 LiFePO4 prismatic pouch 3.2 volt batteries. Now, you can use non-prismatic pouch LiFePO4 batteries, but they tend to be a little larger and they present challenges when it comes to fitting them into the solar panel. But again, it's your choice. Just make sure they're LiFePO4 batteries. You're going to need a power control module, otherwise known as a PCM. And of course, you're going to need a power inverter, and we suggest one that's no larger than 300 watts. You'll also need the following tools and supplies: some wire, solder, electrical tape, a PVC board of 1/8 inch thickness, some drill bits and a drill, pop rivet tool and some pop rivets, wire strippers, wire connectors and splicers, a solder iron, a knife or scissors, screwdriver, jigsaw, circular saw, or table saw is, well, it's kind of always nice to have around the man cave or woman cave, as the case may be. You'll need some epoxy glues, some gloves, a tape measure, and Velcro fasteners. It's best to have a flat surface, like a work table, to assemble your project on. Good lighting is important. Lay down a piece of large cardboard to protect the glass surface of your solar panel before you start assembly. Once you've got your space set to go, start by assembling your battery pack and charge controller first. This is an illustration you may find helpful. In real life, your assembly will look nothing like the wiring reference. While the image on your screen is not to scale as far as the components go, it should give you a better idea of what you're going to be dealing with. So what you're looking at here from the top image to the bottom image is the top side of your battery control module. Then, next down, the bottom side of your battery control module. And that's where you're going to solder the wires that will connect to the batteries, to the solar panel, and to the power inverter. Now, the colored lines you see represent different colored 14 gauge wires. And then, of course, the final thing that you see here is your 4 LiFePO4 prismatic cells. Each cell is 3.2 volts, and they're wired in series to create the necessary 12.8 volt battery pack. It's recommended to cut different color 14 gauge wires to a length of 18 inches. Solder those wires to the power control board first. Then strip the opposite end of the wire and attach an electrical ring terminal with which you can put a small nut and bolt through. Perforate each battery tab of your LiFePO4 batteries with a hole punch so you can attach those ring terminals securely to the batteries. Once you've completed soldering your wires to the battery control module and attaching your wire ring terminals to your batteries, it's time to make it all into a tidy and neat package. I use Gorilla Tape and adhere them to the solar panel with two-sided Velcro strips. The idea is to create the smallest and most compact assembly you can to fit inside the actual solar panel you're using, and then have it securely fastened to the back of the panel. All right, now on to the next step. Most solar panels are visually pretty similar. The front is glass covering very fragile silicon wafers, and the back side has a protective coating and a terminal block with a positive red color and negative black color wire coming out of it. You want to solder those solar panel wires to the battery control module, battery pack now, as you see in the image on your screen. Keep in mind that the batteries are much larger than shown and the power control unit is much smaller than shown. Power inverter is what converts the 12.8 volts from the batteries, which are run in series, to usable household current of 110 volts AC. Power inverters are available in a variety of power outputs, but for this project it's recommended that the output be no greater than 300 watts. That's enough to power lights, most flat screen TVs, laptops, charge your cell phone or tablet, and to recharge your cordless power tools. The higher the rated watt output, the quicker the drain on the batteries, and the shorter the time you'll be able to use your device until it's once again powered up by sunlight. A nice unit, as far as a power inverter is one like this. It contains two 110 volt AC outlets and two built-in USB power ports. I suggest that the combination battery pack and power control unit be mounted to the inside of the back of the solar panel. If you've put together a fairly thin battery pack, you should be able to put some two-sided Velcro on the back of it and attach it to the back side of the panel. Again, you can use zip ties, glue, whatever you feel works for you. I find the best place to mount the power inverter is on top of the fabricated PVC panel you'll cut to the size of your solar panel's length and width. That'll be the bottom side of your solar panel. Epoxy or JB Weld works really great for attaching your power inverter to that plastic. Now, either fabricate a fancy cover or simply cut that piece of PVC board to fit the entire backside of your solar panel. Leave a small hole for the inverter wires to go through before attaching the PVC to the aluminum rails of the solar panel itself. And then run the power inverter wires through that hole and solder those negative and positive wires to the power control module. But let's not get ahead of ourselves. Keep watching. The inverter we use and suggest comes with a cigar lighter plug on the end of the wire. We cut that cigar lighter plug off and leave a length of about 12 inches of wire. You'll notice that one wire has a white stripe and the other is solid black. The wire with the white stripe is positive, red for our illustration purposes, and the black wire is negative. Solder each of those wires to the respective spots on the back of the power control module. It will be the exact same location as the solar panel positive and negative wires are soldered to. Now, there are a lot of different ways to accomplish the final looking pretty assembly, and they're all optional. Use your imagination and let us know how it turns out for you. You know, often it's easier to understand if you see this done. That's what you'll get if you choose to buy my DVD. So get busy. Free electric power is calling your name. Remember, you can get everything you need to do this project on our website. The parts kit and the DVD are affordable and pay for themselves in no time at all. Now, remember, this is a do-it-yourself project. These instructions are just suggestions for one possible way to assemble and build a solar electric generator. You and only you are responsible for what you do. By using these instructions, you agree to hold us harmless for any and all accidents, injuries, incidents, or mishaps that you or others connected to you may incur in the construction or use of this device now or in the future. Thanks for watching. Have a great day.